We are here today at a beverage manufacturer, and we're taking a look at the HANS premium water purification system. This is a 320 gallon a minute system, which is broken down into 4 individual trains. It's done that way for redundancy and also for serviceability. Therefore, you can have virtually zero downtime while you are continuing your manufacturing operation. The purification process happens in several phases. The municipal water here comes in through this large main line. The municipal water is over 400 TDS. It has high hardness, and so we're going to use a multiple phase process in order to get the customer what they need on the back end. This sediment filter is 25 microns. It's designed to remove any debris or other particulates before we move into the next phase, which is the carbon treatment. These carbon treatment modules are going to remove any chlorine that's in the water, any other volatile organic compounds, or things like sulfur that affect taste. We have an additional sediment filter. This is all the way down to 5 microns. This is to make sure that we're removing any carbon fines or anything that was missed during the initial phase of sediment filtration. Next, we have our chemical injection system. This is used in place of a traditional water softener, and it is a huge reduction in operating cost to provide the system the anti-scalant features that it needs in order to be processed with RO. You're not going to need any salt with this, and you're eliminating thousands of pounds a day required for softening the water. After the chemical injection phase, we go into the redundant pump. This is a boost pump, which is intended to boost the pressure of the water coming in before it gets to the RO. The boost pump has complete redundancy, and so it typically operates with both pumps working in unison. However, if one pump goes down, the second pump has the ability to take up all the slack, so you have virtually zero downtime. The final step in the purification process is the actual RO itself. The RO is going to remove virtually all of the TDS and other contaminants that are remaining. The system itself is also designed so that it is adaptable to changes in the inlet water, and it will adjust the amount of rejection and recovery in order to optimize the outlet water for the specifications required by the customer. So each individual RO train is capable of around 80 gallons a minute, and the final phase is to move the water into this large 12,000 gallon retention tank. And with our system operating at 320 gallons a minute, we can fill this in just under 40 minutes. You've got a very large capacity system able to give you what you need, product water on demand.